Welcome to the video lecture series of data structure. Our today's topic is binary search tree and insertion in binary search tree. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. See students, outlines, the first we need to understand that what do we mean by the binary search tree. Then we will talk about that how can a searching operation be performed in binary search tree. Then we will talk about the insertion in binary search tree, and the last we will see the examples for the insertion. Okay, so let's begin with the very first, the definition of binary search tree. So students, as we all know that binary search tree, it's itself a binary tree in which the smallest values are situated on the left side of the node and the largest value are situated on the right side of the node. Fine. So here let me tell you that if this is a figure, if this is our example, then if you can see the root node 80, fine, the root node is 80. So whatever the smallest value from 80 are situated on the left side of the 80 and the largest value than 80 are situated on the right side of the 80. For your convenience, I am just highlighting with the green and the red color. Fine. If you can see, the 65 is a value is smaller than the 80, that's why it's on the left side, and the 98 is a value that is a greater than 80, that's why it is on the right side. Fine. So let's begin on the next. So here the next is, students, the searching in binary search tree. See, searching in binary search tree is very much easy. Okay, how? Let's see. First, you just need to compare your key value. Okay, students, what do we mean by the key? Key is a value that we need to search in our this tree. Fine. And the key value that we need to compare with the each and every node value. Now, suppose students, if you want to find out the 85, if you want to find out 85, then how you can do it that? Okay, see, first you need to always start any operation in binary search tree from root node. Remember this that always start any operation in binary search tree from root node. Fine. So students, here suppose your root node is 80. Your root node is 80. Okay. And if I want to search key value 85, then how it begins? Let's see. Here first you just need to compare your value with the 80. Okay. Suppose if your value is not greater than 80, then just move towards the left side, and if it is greater than 80, then just move towards the right side. Fine. So if I want to search 85, so first I need to compare 85 with 80. 85 with 80, it's greater than 80. So I just find out on the right side of the 80. Okay. Now on the right side of the 80, I got 98. Fine. So what I'm going to do is I am going to search 85 again. Okay, compare 85 with 98. Compare 85 with 98. So students, here you can see that 85 is less than 98. Okay, so you are just going on the left side of the 98. On the left side of the 98. So on the left side of 98, you will compare another node. So going to compare 85 with that node value. Now compare 85 with 85, you will find your value. So here in searching in binary search tree, you always need to start with the root node. Here I just values are there where I am just placing 80 on the left side, 65 on the left side of the 80. Then next is 30. Okay, so you can say that 30 is less than 65. So obviously it's on the left side. Okay, such like this, the other values are there. Okay, so smallest value must be on the left side of the root node and the largest value must be on the right side of the root node, and you just need to compare your key value with the root node value. If your key value is smaller, then go on the left side. If your key value is greater, then search in the right subtree. So that's your searching operation. Okay, so now let's begin with the next slide. Students, the next slide is insertion in binary search tree. Okay, so how we are going to insert values in binary search tree? It is very much easy. The smaller values must be on the left side and the greater values must be on the right side. Okay, so don't wasting more time. Let's begin with the examples. Okay, so here you can see that insertion in binary search tree, students. We have one example. It goes like this. We have 50, we need to insert 50, 60, 25, 40, then 30, 70, 35, 10, 55, 65 and 5. Okay, so these are the values which we need to insert in our binary search tree. Or it may be asked in your exam that construct a binary search tree for given this values. Fine. So what you need to do is you just need to start with the very first value. The very first value here is 50. So students, 50 becomes our root node. Fine. So here the first is 50. So the 50 becomes our root node. This is step 1. You need to write in a notebook such like this: step 1, step 2, step 3, step 4 and go on. Fine. Whatever the values that we need to insert, okay, that number of steps we need to perform. Okay, the very first step is to make a root node, that is 50. Okay, so here it is 50. Now the next value, students, what is our next value? What is our next value? Next value is 60. Next value is 60. So now just compare your 60 with root node 50. Compare your 60 with root node 50. Now tell me, is 60 is greater than 50? Yes. Is 60 is greater than 50? Yes. So where we need to insert it? We need to insert on the right side, of 50. So it goes like this: as 60 is greater than 50, we need to insert 60 on the right side of the 50. Now let me take the next value. Students, the next we have 25. Next we have 25. Okay, so first again, whatever the operation you going to perform on binary search tree, for that you first need to compare from the root node. Either it is insertion, deletion or searching, you just need to compare the 4 values with the root node. Okay, so here in the root node we have value 50. So just compare 25 with 50. Now tell me, 25 is less than or greater than 50? Yes, obviously 25 is lesser than 50. So we need to insert 25 on the left side of 50, right? So here it is, 25 is on the left side of 50. Fine. Okay, so let's move further. The next value that we need to insert is 40. Okay, so here it is 40. So from where you need to start the comparisons, students? You need to start your comparisons from root node 50. So compare 40 with 50. Compare 40 with 50. Now we all know that 40 is less than 50. Fine. So obviously go on the left side. Go on the left side. Now on the left side of 50 we found value 25. We found the value 25. So again, just comparing 40 with 25, you can see in the slide also, we are just comparing 40 with 25. Okay, what we did, first we compare 40 with 50 and then compare 40 with 25. Okay, so 40 is greater than 25. Okay, so we need to insert 40 on the right side of 25. So here it is, as 40 is greater than 25, we need to insert 40 on the right side of 25. Okay, so let's move further. The next value we have 30. We have 30. Fine. So first compare 30 with which one? 40 or 60? First compare 30 with 50. Okay, because any operation on binary search tree, we are going to perform comparison with root node. Okay, so first compare 30 with 50. 30 is less than 50. 30 is less than 50. So just move towards the left side. Just move towards the left side. Okay. Now on the left side of 50 we have 25. On the left side of 50 we have 25. So now compare 30 with 25. So obviously 30 is greater than 25. So just move towards the right side of 25. Okay. So on the right side of the 25, students, you found 40. You found 40. Now compare again 30 with 40. 30 with 40. Okay. So obviously 30 is less than 40. So where to go? Where to go? Left or right? So we need to move towards the left side of 40. Fine. So the left side of the 40 we have 30. So here it is. Okay. So now you will get better idea that where to insert, where to not. But always start comparison from the root node. Fine. So let's start. The next value, students, we have 70. Next value we have 70. Fine. So you can see that 70 comparison with the 50. Okay. So 70 is obviously greater than 50. So we need to move towards on the right side of 50. On the right side of the 50, students, we found 60. We found 60. So first we just compare 70 with 50. 70 with 50. So obviously it is on the right side of the 50. Now very next step that you need to take is compare 70 with 60. Okay. So 70 is greater than 60. 70 is greater than 60. Okay. So let's insert 70 on the right side of the 60. So here it is. 70 is greater than 60. So it is already inserted on the right side of the 60. Fine. Now what is the next value? Next value is 35. Okay. So this is step number 7. Next value is 35. So first we need to compare 35 with the 50. Now 35 is less than 50. 35 is less than 50. So move towards the left side. Okay. On the left side we found 25. Again compare 35 with 25. 35 is greater than 25. So let's move towards on the right side. On the right side, students, we have 40. 35 is less than 40. Again, see, 35 is less than 40. So we need to move on the left side of the 40. Okay. So that there we found 30. So now you need to compare 35 with 30. See, 35 is greater than 30. So at last we need to insert 35 on right side of the 30. On right side of the 30. So here it is. On the right side of the 30, we are going to insert 35. Fine. So now next value is 10. Next value is 10. So start compare from the root node. First comparing 10 with 50. So here the 10 is lesser than 50. So we just move towards the left side of the 50. Then compare 10 with 25. 10 is again lesser than 25. Okay, 10 is again lesser than 25. So move towards the left side of the 25. Okay, so after all 10 is we're going to insert on the left side of 25. So here it is. 10 is less than 25. That's why 10 is inserted on the left side of 25. Fine. So let's move ahead. The next we have 55. 55. So students, start comparing the value 55 with 50. Okay. So 55 is greater than 50. 55 is greater than 50. So just move towards the right side. Okay. Just move towards the right side. So compare with 60. Compare with 60. So now 55 is less than 60. 55 is less than 60. So where to go? On left side of 60. On left side of 60. So students, on the left side of the 60, we are going to insert 55. Okay. So first compare with 50, then 60, and here it is. 55 is inserted. 55 is inserted on left side of 60. Fine. Now the next value we have 65. Next value we have 65. So students, 65 is greater than 50. We are obviously going to start comparison with the root node value. At the root node we have 50. So first compare 65 with 50. Okay, 65 is greater than 50. So let's move on the right side. On the right side subtree, we first found 60. So compare 65 with 60. Compare 65 with 60. So obviously 65 is greater than. So move towards the right side. 70, 65 is less than 70. So at last we are going to insert 65 on the left subtree, on the left side of 70. Okay. Now the last value we have 5. Last value we have 5. So here in the 5, first compare with the 50. 5 is less than 50, move towards the left side. 5 is less than 25, move towards the left side. 5 is less than 10, move towards the left side. Fine. So at last 5 is going to be inserted on the left side of 10. So this is the insertion in binary search tree. Okay. Now question coming in the mind that, sir, should we need to perform each and every step? Yes, you have to perform, because it might be asked in 5 to 7 marks. So at that time you need to show each and every step. Total 11 steps that you need to write in your notebook or in the exam paper. Fine. So next, this is our final answer. Now tell me, is this binary tree? Yes or no? Is this binary tree? Yes, it is. How? Because it contains maximum 2 children. Now, is it binary search tree? Yes, it is. How? Because all the small childs comparable to the node are on the left side and greater childs are on the right side. Fine. So here is the binary search tree insertion. So that's it for today's lecture, students. Thank you so much.